Alright, let's look at the homework 7.8, problem number 4. Alright, let's evaluate this improper integral. Alright, so first thing I would do is I'm going to do the partial fractions decomposition. So we have 1 over v squared plus 6v minus 7. Alright, so we can factor out the denominator. So we have v, and let's see, v minus 1 times quantity v plus 7. Right? So since these are just distinct linear factors, we can simply split that into a over v minus 1 and plus b over v plus 7. Alright, so let's see, put them back together. Alright, so we have a times v plus 7 plus b times v minus 1, and the denominator is just v minus 1 times v plus 7. Right? So we just need to make sure that the numerators, these guys, match up. Right? So I'm going to, so I want to find a, so I'm going to try to plug in, let's see, v equals 1. Right, then we'll get v1 plus 7 is 8. So 8a is equal to, the other side is 1. Right, so divide through by 8. We found a to be 1/8. Right. Let's try v equals negative 7. Then you have a negative 7 minus 1, so it's a negative 8b. And again, the other side is 1. So we can divide through by negative 8 to get the b to be negative 1/8. Alright, so let's rewrite this integral. Right? So this is going to be an integral from 2 to infinity. Right? So both numbers are 1/8 and the other one is a negative 1/8. I'm going to just pull out the 1/8. Right? That way you can just do a 1 over v minus 1 and a minus 1 over v plus 7, right, with respect to v. Alright, so this is just the partial fractions. Alright, then we have to take care of this infinity. So we're going to use, since this is basically the troublemaker, so we're going to just replace that by t. So this is going to be, right, so 1/8 is just a number, constant, so I'll just put it out here. Then we have a limit as t approaches infinity, and you have an integral, right? 2 is okay, but the infinity, we replace it with t, right? Then we have everything else the same, so I'm going to just say, I'm just going to copy 1 over v minus 1 minus 1 over v plus 7 with respect to v. Right? Then I'm gonna go down here so that we have more room. Alright, so this is gonna be equal to 1 over 8, and the limit as t approaches infinity. Right? We can take the antiderivative of 1 over v minus 1. So that's natural log of absolute value of v minus 1, right, minus, and natural log of absolute value of v plus 7. Right? Then you're going from 2 to t. Right? Then we just plug it in. So we get, before we do that, we can probably do this. Right? So we can combine those two guys together as natural log of absolute value of, right? So you have a subtraction, so we can write it as a division inside. So it's a v minus 1 divided by v plus 7, right? Then plug it in, right? So you have a 1/8, and we have a limit as t approaches infinity, right? So you have a natural log of absolute value, plug in t, so it's going to be t minus 1 over t plus 7, right? And minus natural log of, right, plug in 2, so it's going to be 2 minus 1, so it's going to be 1 over, and 2 plus 7, so it's 9, right? So, wrong place. So we are taking the limit of this guy. All right, so here, what it does is, so we as t approaches infinity, right? So this let's look at just inside part, t minus 1 over t plus 7. So since the top has a degree 1 and bottom has a degree 1, so it's going to be just a leading coefficient over leading coefficient, which is 1 over 1. So this guy actually approaches 1 as t approaches infinity, right? Which means that the natural log of 1 is actually 0. So this guy approaches 0. All right, so what you get is really, right? So it's going to be just 1 over 8. And this is negative. I'm going to actually take this negative sign and put it up here. So it's going to be 1 over 9 to the negative 1 power. So that's a long way of saying 9, right? So this is just going to be 1/8 natural log of 9, right? So that's the value of the improper integral. All right, so let's double check. All right, we got the so this is going to be convergent because we got a finite value. Right, we have a natural log of 9. All right, 9, and divide by 8. All right, so let's submit for testing. All right, it came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.